Hello guys, welcome back to LeetCode. Today let's practice medium level question, subset. So this question is very classical for permutation or combination. So let's start. Given an integer array nums of unique elements, so that is a unique elements, and we should return all possible subsets, the parse set. And the solution set must not contain duplicate subsets. And we can return the solution in any order. So here is the example one. So in this nums array, there are 3 elements. For each element, we can whether choose to put it or not to put it in a subset. Like in this empty subset, we choose not to put any of the elements in this subset. So this one is an empty subset. And for this one, a subset that contains only one element. That means we choose to put this element and choose not to put the 2 and 3. And for 2, we choose to put this one, and also we can choose to put 2 elements. So here are 1 2 or 1 3 or 2 3, and we can also choose to put all of the elements. So that is 1 2 and 3. So after checking the example, now I want to remind you of some of the trap. Okay, though I think that is not a trap, but that is kind of a specific condition you have to pay attention to in this question. So the first thing is that we cannot contain any duplicate subset. So what is a duplicate subset? Like this one, if there is a subset of 2 elements, 1 and 2, and here is another subset with the same elements but with different order. Let's say that is 2 and 1. We see, or we can say that these 2 are duplicate subset because the elements are the same, although the order is different. Okay, and the second thing we have to pay attention to is the nums only contains unique elements. So let's think about if there are some duplicate or some same elements in the nums, what will happen? So if there is an array with duplicate elements, like we have 2 and 3. So for one subset, we decide to take these 2 and these 3. And for another subset, we decide to take the middle 2, this one, this 2 and the 3. Then these 2 actually are the same subset, or they are duplicate subset, although these 2 comes from different elements in the nums array. So if the nums array have some duplicate elements, then we have to deal with this special condition. But since in this question all the nums has unique elements, then we don't have to deal with that. So for this question, we can solve it using recursion or using backtrack, but now I want to use the bit manipulation. So for the example 1, now we have the nums, and we have 1 and 2 and 3. So just like what I say, we can choose, first we can choose to put only one element in the subset. So we choose this one. So when I choose that, I will mark it as a circle or a 0. So I'll put that here. And for the second elements, I don't want to put that because I just want to put one element in this subset. So for these 2 and 3, I don't want to put it. So here is one subset, and another subset is I choose not to put this one, but I want to have 2, and I don't want to have 3, or I can also have only 3, right? And then I can have two elements in the subset. So I have 1 and 2, and then I don't want to have 3, or I can have 1 and 3. Okay, etc. So since there is just 2 representation of whether an element exists in a subset or not, actually we can turn it into the binary representation. Like we can turn the 0 into, okay, the circle into a 0. So in the binary representation, here is a 0, and for this one, this is 1. Oh, sorry. So for the binary representation, when I want to have that element in my subsets, that means I pick it up. So this 1, and for the cross, that means I don't want to pick it, so that is a 0, and this is 0, and this one is 0, and this is 1, and this is a 0. So 0, 0, and this is 1, and this is 0 and 0, this is 1 and 0 and 1 and 0. So how many number of representations I will have here? So in total, I will have 2 to the power of n representation. So how does it come from? It comes from, like, for each element, like this one, I have 2 choices. So this one have 2, and this one also have 2 choices, and this one I have 2 choices. So in total, I will have 2 to the power of n choices. I have, so for the binary representation, 2 represent 8 different combination of subsets. So first I can have a 0 and 1 and 2, 3, 4, 5, 6, 7. So for the 0 is binary representation is 0, 0, 0, and this one is 0, 0, 1, and this one is 0, 1, 0, and this one is okay. And now let's use some it's just look some bit mask. So here is the index 0, and here is index 1 and index 2. So we have nums equals to 1 and 2 and 3. So here all of the index is 0, so that means we don't want to take any of the number from subset from the nums. So this subset is an empty subset, and for this one, we can check that only the 0 index is 1. So the 0 index of nums is 1. So this one is just 1 element, and this one is the first index of the nums. So that is 2. And this one is the 0 index and the first index in the nums. So that is 1 and 2. So this one is just the second index element. So that is 3. Here is 0 and second. So that is 0. This one and second. So that is 1 and 3. Okay, and here is 2 and 3, and here is 1 and 2 and 3. Okay, so we can turn the number from the decimal representation into the binary representation, and then using some bit manipulation to take the every digit in the binary representation, and to check if that in digit is 1, then we want to take the corresponding number in the nums to put that into the subset. Okay, so how do I use the bits? So for, let's say, we have a binary representation of 5, and the binary representation is 101. So first I want to check only the least digit. So I can use 101 and use a bitwise operator. So that's N001. So that means I will have 0, 0, and 1. So since this number is 1, that means I would like to take the 0 index. So that means I will have a subset, or I will call it current in my code. So I will take 1 here. And then I will right shift this 101 by 1. So that means now I will go to 1, 0. Why? Because after I have already checked these digits, then I want to check this digit. So now I will remove this 1 by shifting the 101 right shift by 1. So I will get 1, 0. And then also use N1. So here I will get 0 and 0. So since this value is 0, so that means I don't want to take the second digit or the second index in the nums. And then again, I will right shift 10. So right shift 10 will go to 1, and then I will use N1. So this is 1. Okay, so this is 1. That means I want to put the third element from the nums. So here I'll have 1 and 3. And this is the subset that corresponding to 5. Okay, so for the time complexity and space complexity, for the time complexity, we will have this number of iterations to build the subset. So how many number of iterations we have to go? That is the number of the subset itself. So the number of subset is 2 to the power of n. And for each iteration, I will have to go through this 101 and then 10 and then 1. So I will right shift the number by n times. So for every iteration, it will take n times to right shift until there is just 1 digit. So that is the time complexity. And then for the space complexity, okay, so if we don't count the output, the output in the space complexity, then the space complexity of my code will just have this curve subset. And the length of this curve subset is, at most it will contain n number of the elements from nums. Okay, so I forget to mention that the n, it means the length of the nums. But if you are required to also conclude the output in the space complexity, then that is the same as the time complexity, because we will have 2 to the power of n subsets, and for each subset, the length of each subset will goes at most n. So that is the space complexity. Okay, now let's start to coding part. Now let's start the coding part. So first of all, let's declare res as the output of this function. And then we will have to create 2 to the power of length of n times the number 2, and then change it to the binary representation, right? So I will call it mask. So that is the bit mask. Two to the power of length of nums. So for each mask, I will have a subset. Then I will call it cur. That means the current subset I'm working on. And for each subset, I have to iterate the nums and then check if I want to put every single element in the nums into the current subset. So how do I check it? I will check the last digit of mask. If that mask of the digit of the mask is 1, that means I want to put the number in the subset. So I will use the bit operator n. So here it will check the last digit. So if this one is a 1, then I will append the number in the current subset. Okay, so here I forget to iterate the nums. So for the indexing range of length of nums. So if that is a 1, then I will append that number. Okay. And then I will right shift the mask by 1. Okay. And then after finish 1 mask, then I will like to put the current subset in the result. So we can return the result. Let's run the code. Okay, and submit. Okay, it passed. Thanks for watching. If you like my video, don't forget to subscribe to my channel and share and like my video. See you next time. Bye.